Today we will discuss engineering thermodynamics. Engineering right? Today, last class I have discussed about various processes. Today I will continue that theory. Clear? Now prove that Cp minus Cv is equal to R. Cp minus Cv is equal to R. I will prove this. Very important question. Short question. 6-mark question. Consider m kg of gas being heated at constant pressure process. Let m is equal to mass of the gas, P is equal to pressure of the gas. V1 is equal to initial volume of the gas. V1. V2 is equal to final volume of the gas. Similarly, P1 is equal to initial temperature of the gas, T1. T2 is equal to final temperature of the gas. Clear? Cp is equal to specific heat at constant pressure. Cp is equal to specific heat at constant volume. R is equal to characteristic gas constant. Q is heat supplied. But Q is equal to M Cp T2 minus T1. Q. W is equal to what done? P into V2 minus V1. PV2 minus PV1. MR T2 minus MR T1. Clear? This is equal to MR T2 minus T1. This what done is W is equal to. Change in internal energy. Change in internal energy, del U M CB T1 is T1. Now, according to law of conservation of energy, what is Q is equal to W plus del U. Its applied is equal to work done plus change in internal energy. What is Q? M Cp T2 minus T1. W is equal to Mr T2 minus T1. Del U is equal to M Cb T2 minus T1. Clear? This T2 minus T1 cancels both sides. M also cancels both sides. Now, what is Cp is equal to? R plus Cb. This implies Cp minus Cb is equal to R. Prove. Clear? Now, I can derive another formula from this equation. Divide both sides by Cb. Divide both sides by Cb. So, Cp by Cb minus C by Cb is equal to R by Cb. Cb cancels. What is this? Gamma. So, gamma minus 1 is equal to R by Cb. What is it? Cb is equal to R by gamma minus 1. This is another formula. Again, C by Cb will R, gamma, what is Cp is equal to? Gamma Cb, gamma what is Cb? R by gamma minus 1. So, Cp is equal to gamma into R by gamma minus 1. Clear? Again, what is Cp and Cbr? Again, Cp and Cb will R, multiply both sides by M. What is M is equal to? Molecular mass. Where M is equal to molecular mass. Clear? So, M into Cp minus M into Cb is equal to M into R. What is this? Ru. This is Cp mole minus this is Cb mole. Ru. Clear? Where what is Cp mole? Molar associated at constant pressure. What is C mole? Molar associated at constant volume. What is Ru? Universal gas constant. Where Cp mole is equal to MCP. M into Cp. What is this? Molar specific heat at constant pressure. Similarly, C mole is equal to M into Cb is equal to molar specific heat at constant volume. Clear? Are you? What is Ru is equal to? M into R. Universal gas constant. Universal gas constant. What is its value? 8.314 kilojoule per kg mole Kelvin. Clear? This is value of Ru. Now, this is about relation between Cp, Cv and R. Now, I will make the expression PV to gamma constant. Adiabatic process formula. Next question. The subject is mainly used for diploma and degree both students. Diploma, degree and post science thermodynamics chapter. Clear? The subject is used for diploma students, degree students, and post students for thermodynamic portion. Heat chapter. Next, derive the expression P beta gamma is constant. Product process for adiabatic process. Clear? Derive expression P beta gamma is P beta to the power gamma is constant. Very important question. 6-mark question. These are all 6-mark questions. Answer. Consider m kg of gas being expanded or being heated by supplying heated from temperature T1 to T2. Clear? Let Cp is equal to heat at constant pressure. Cp is equal to heat at constant volume. But gamma is equal to Cp by Cv. Clear? Now, what done? What is that done? dW is equal to P into dV. P into dV. What is P? PB, PdV, clear? P pressure, dV change of volume. Change in internal energy. Change in internal energy. CB dt, heat transferred. Q or dQ. According to law of conservation of energy, according to law of conservation of energy, what dq is equal to d del plus del u. Clear? So dq is equal to dw p dv plus cb dt. This additive process. So for additive process, dq0. Clear? We derive the expression for additive process. So for additive process, no transfer of heat. So dq is equal to 0. Apply this equation to adiabatic process. That is, dq is equal to 0. So here this is 0. But pdv is equal to pd plus cb dt 0. Clear? Now also what is pp is mrt for m kg of gas. For m kg of gas, pp is rt for 1 kg of gas. Clear? We will multiply both sides m. This m we can cancel, so divided by m. So better take for 1 kg gas. So differentiating both sides. Differentiating both sides. So pdv plus vdp r dt. Clear? But dt is equal to pdv plus vdp r. Put this for value in equation 1. This equation 1. Clear? Putting this value here. Putting the value of dt in equation 1. Putting the value of dt in equation 1. So from equation 1, from equation 1, pdv plus cb into dt or dt, pd plus vd by r 0. Clear? Clear? Multiply by r, this r. Now multiply R LCM R into PdV plus CB into PD plus BDP 0 whole LCM R. So R cancels, but multiply by R 0. Put R is equal to CP minus CB. Here put R, value of R. So CP minus CB into a PdV plus CB into PdV plus BDP 0. Clear? Put here value of R. Now open the bracket. CP into PdV minus CB into PdV plus CB into PdV plus CB into BDP 0. PdV cancels. Next, CP into PdV plus CB into BDP 0. Divide both sides by PB CB. Clear? Divide this. So CP into PdV by PBCB plus CB into BDP by PBCB 0. 0 by PBCB 0. Clear? So it cancels PP, this cancels CBCB, BB. This is equal to CP by CB into D by B plus DP by P 0. Clear? This is gamma. Integrating both sides. Integrating both sides. Gamma into integration of D by B plus integration of dP by P integration of 0. This is gamma into ln V plus ln P constant. Integration 0 constant, difference constant 0. Clear? Integration of 0 is 0 constant. This is equal to ln B to power gamma plus ln p constant. M ln n, ln m to the power n. This is ln n plus ln n, ln m into n. So ln e b to the gamma constant. Clear? This implies is ln by c. So what is p to the gamma is equal to constant, e to the power c constant. This answer. Clear? E to the power here ln means e. Here e to the power c constant. So p to the gamma is equal to constant. This is expression for p to the gamma for additive process. Clear? Now we will discuss the relation, find out the value of gamma in additivity and polytropy process. Today I done a new subject, mechanics of solid. Clear? This is for third semester and third sem BTech and diploma both students. Strength of material, mechanics of solid. Today I have already given that subject to our YouTube channel. This is thermodynamics subject. Next month I will give you fluid mechanics. In this session I will give 4 subjects: mechanics, thermodynamics, mechanics of material or mass, and fluid mechanics. Clear? Now this is thermodynamics. Value of gamma in adiabatic and polytropy process and polytropic process. For additive process, P to gamma is constant. Clear? This is equal to P1 beyond to gamma is equal to P. Take it on both sides. Take it on both sides. Clear? So ln P1 beyond to gamma is equal to ln P to power of gamma. Not this. This is P1 beyond to gamma. Clear? This is P2 clear? Ln m into ln n, ln m plus ln n. So this is ln P1 plus ln beyond to the power gamma is equal to ln P2 plus ln b to power gamma. So ln m to the n, n ln m. This is ln P1 plus gamma ln B1 is equal to ln P2 plus gamma ln V2. Clear? This is bring gamma one side and ln P1 P2 another side. Is equal to gamma ln V1 minus gamma ln V2. Clear? Is equal to ln P2 minus ln P1. P1 one side, P1 P2 one side, P1 P2 another side. Clear? Now ln m minus ln n, ln m by n. So gamma common, ln V1 by V2, ln P2 by P1. So what is gamma is equal to ln P2 by P1 by ln V1 by V2. The value of gamma. Clear? Ln P2 by P1 ln V1 by V2. Similarly for polytropic process. For polytropic process, what is n is equal to ln P2 by P1 whole by ln V1 by V2. Clear? This is value of gamma, value of n. Radioactivity and for polytropic process. Now I have derived the expressions for relation between P, B, T, pressure, volume, temperature for radioactivity and polytropic process. Now relation between pressure, volume, temperature in adiabatic and polytropic process. Polytropic process. Now, number one, pressure and temperature, volume and temperature, volume and temperature. One. Now, we know what P1 by P1 V1 by gamma is equal to P2 V2 by gamma. Clear? What is P1 by P2 is equal to V2 by 2 by gamma. Equation 1. Clear? Also, from combined gas law, P1 V1 by T1 is equal to T2 by T2. What is P1 by P2 is equal to V2 by V1 into T1 by T2. This equation 2. Clear? 1 to 2, equation 1 and 2. equating 1 is to 2. Left side equal, so I'll equal right side. Now V2 by V1 into T1 by T2 is equal to V2 by V1 to the power of gamma. This is power 1. Clear? So T1 by T2 is equal to V2 by V1 to the power of gamma minus 1. Similarly, if I will apply for poultry process, or T2 by T1 is equal to T2 by T1 is equal to V1 by V2 power of gamma minus 1. Clear? Similarly, for poultry process, polytropy process, T2 by T1 is equal to V1 by V2 power of n minus 1. This relation between temperature and volume. Clear? Now I will derive relation for temperature pressure. Number 2, temperature and pressure. Clear? Now from equation 1, V2 by V1 is equal to P1 by P2 power of 1 by gamma. Clear? Or V1 by V2 is equal to V2 by P1 to the power of 1 by gamma. This is equation 3. Similarly, from combined gas law, from combined gas law, what is combined gas law? V1 by V1 is equal to V2 by V2. Right? To find out what is V1 by V2, this implies V1 by V2 is equal to T2 by P1 into P1 by T2. This is equation 4. Clear? This is V1 by V2, this is V1 by V2. So equal to equation 3 and 4. Equal to equation 3 and 4. This equation 3 is or 4. Clear? So from equation 3 or from equation 4, T2 by P1 is equal to into T1 by T2 is equal to V1 and V2 is equal to this V2 P on the power of 1 by gamma. Clear? This is V1 and V2. This is V1 and V2. Now, what T1 by T2 is equal to? V2 P on the power of 1 by gamma minus 1 is 1 power 1. So P2 P on the power of 1 minus gamma by gamma is equal to T1 by T2 is equal to. Clear? Or revise both sides. T2 by T1 is equal to. Clear? P2 by P on the power of gamma minus 1 by gamma. This common minus. So this power minus cancel each other. So T2 by T1 is equal to P2 by P on the power of gamma minus 1 gamma. This is equation 5. So this is for added process. Similarly, for polytropy process, T2 by T1 is equal to P2 by P on the power of n minus 1 by n. Clear? This is for poultry process. This is for additive process. Now, next question, long question, very important question. Derive the expression for what done in polytropy process. Derive the expression for what done in polytropy process. In polytropy process. Right? Very important question, 60 marks. This is a long question. This is 60 marks, long question. Last class, I have discussed the what done. No, for heat transfer, not what done, heat transfer. Heat transfer. Heat transfer in poultry process. In poultry process. Clear? Last class, I have discussed I have derived the formula for what done, change in internal energy, change in enthalpy for all processes. Only this expression I have not derived. Now I will derive. Clear? Consider m kg of gas being heated by polytropy process. Clear? Let P1 V1 T1 is equal to initial condition of the gas. P2 V2 T2 is equal to final condition of the gas. Final condition of a gas. Now Cp is equal to specific heat at constant pressure. Cp is equal to specific heat at constant volume. What is gamma? Cp by Cb. What is R? Cp minus Cb. Clear? The formula I have already derived. Now I will apply this formula, these equations to find out heat transfer in polytropic process. Now what done? What is what done for polytropic process? What done? W is equal to P1 V1 minus P2 V2 by n minus 1. This is already I have derived. Last class this is already I have derived. Similarly, change in internal energy delta U is equal to m Cb T1 is T1. Clear? What is Cb? What is Cb? We know Cp minus Cb are, so divided by Cb, so Cp Cb minus R by Cb. Clear? This is gamma. So gamma minus 1 is equal to R by Cb. What is Cb is equal to? R by gamma minus 1. Put the value here. Put this value here. So del U is equal to. Now del U is equal to, change del U is equal to m Cb R by gamma minus 1 into T2 minus T1. Clear? Value of Cb. Multiply by Mr to T2 minus T1. So del U is equal to Mr T2 minus Mr T1 by gamma minus 1 is equal to V2 V2 minus T1 V1 by gamma minus 1. Del U is equal to. Is what done? Is change in internal energy del U. Now, according to law of conservation of energy, clear? According to law of conserve some energy. What is Q is equal to? Double flow del U. So what is Q is equal to? Roll means V1 minus V2 by n minus 1. For this is equal to V2 minus V1 by gamma minus 1. Clear? So make negative, find out negative common from this side. So Q is equal to V1 minus V2 n minus 1 minus V1 minus V2 by gamma minus 1. Find V1 minus V2 common. This is equal to V1 minus V2 by common 1 by n minus 1, 1 by gamma minus 1. Clear? So what Q is equal to V1 minus V2 LCM n minus 1 into gamma minus 1, gamma minus 1 minus n plus 1. 1 cancels. Clear? This is Q is equal to gamma minus n by gamma minus 1 into P1 V1 minus P2 by n minus 1. This is what done? Heat transfer for polytropic process. What is this? What done? This implies Q is equal to gamma minus n by gamma minus 1 into what done. Clear? Very important derivation expression for heat transfer in polytropic process. Next I will give some formula. Now I will give some formula regarding all these 5 processes. Right? Now, next class I will do a table which consists of all these 5 processes: work done, heat transfer, change in internal energy and enthalpy. Then I will do some problems. Clear? Thank you. Please make all these channels, all our videos, like, share and subscribe. Clear? This is very important for me and also for you. Thank you.